Good day, trainees, my students, and welcome to another exciting topic on digital technology or digital techniques. I remain Engineer Felix Izoke, and I'll be taking you through this course. The word digital has become part of our everyday vocabulary because of the dramatic way that digital circuits and digital techniques have become so widely used in almost all areas of lives, like the computers. Computers are examples of digital technologies. We want to talk about automation. We want to talk about robots. We want to talk about even the medical science in transportation, in technology, entertainment, space exploration, and so on and so forth. You can find digital techniques. So digital techniques has taken over our analog world. We shall be expanding this as we progress in this topic. And we're going to be looking at some underlying terminologies as we move along in this topic. First of all, we want to look at digital and analog. What do we mean by analog? Analog systems. In science and technology today, businesses and in fact most all other fields of endeavors, we are constantly dealing with quantities. Quantities are things that can be measured, monitored, recorded, manipulated arithmetically, observed, or in some other way utilized in most physical systems. Now, it is important that when dealing with various quantities, that we are able to represent the values efficiently and correctly. Now, there are two basic ways of representing these numerical values of quantities. You can either represent them in analog form or in digital form. What are analog and what is digital? Analog representation are quantities that can be represented by voltages, currents, even pressure, or some meter movement that is proportional to the value of that quantity. Basically, analog quantities vary over continuous ranges in time. So whatever signal that we receive, if we plot a graph of voltage against time, for example, and we have fluctuations over time, changes over time. If this is from 0 to probably say 10 seconds, here could be say 4, 2, 4, 8, 10. So over time, you don't have a continuous value. So this can be referred to as what? As an example of analog. So we know that voltages, current, even pressure, sometimes cannot be maintained constantly. So with time, the signals vary. Okay? What of the digital representation? In digital representation, the quantities are represented not by proportional quantities, but by symbols called digits. For example, let's look at the digital watch, which provides the time of day in form of decimal digits, which represent hours or minutes, and sometimes seconds. As we know, the time of the day doesn't remain constant. It changes with time. But in the digital watch or the digital clock, the reading does not change continuously, but rather increases in discrete steps. That is, 1 per minute or 1 per second. For example, like the watch which you may be putting on there is an example of an analog device because the time of the day changes because you can see the second hand ticking out. But in the digital world, you can see that if we have, for example, 9, it will take some time before it gets to 10, and then to 11, and so on and so forth. So these are what we call discrete steps, changing one step at a time. So in other words, the digital representation of time of day changes in discrete steps as compared with the representation of time provided by an analog watch, where the dial reading changes continuously. So for this case, if you are to illustrate the digital signal, we will just have breaks in this. So we'll have something like this. Okay, so these are in discrete steps. So they are not continuous. So you can see the break. So these are discrete steps. Okay, so this is the representation. Okay, in graphical form. So it takes some time before you move to the next step, and then to the next step, and then to the next step. Unlike the analog, where it changes for every given second. For every given second, you can observe the change. So the major difference between an analog and digital technique is that the analog signal is continuous, or the analog representation is continuous, while that for digital increases in discrete steps. Now, there are some advantages and disadvantages which have been given to you in your material. So I would like you to read it up so that you can actually look at the advantages of the digital techniques over that of the analog techniques, as well as the limitation of digital techniques. However, I would like to mention here that the major drawback in digital technique is that the real world in which we live in is what is analog in nature. By analog, it means that, for example, this speech I'm putting up, there are different tones, there are different variations in the way I talk. The pitch are different. In digital world, however, we have zeros and ones, that is binary. In the real world, we count to 10 decimal from 0 to 9. We have 10 digits, our fingers are 10. But in the digital world, we have what? We have ones and zeros. So it's either true or false, on or off. However, for us to communicate with our digital systems or digital device like the computer, among others, there must be a way which we can actually transform those analog representations to digital representation for processing. And this can be done in 3 steps. Number 1 of the step is how to convert. You must have a device, or that device must be able to convert the analog signal received to digital. And then we also have the way of processing it. There must be a way it is what? Processed. So the digital information, let me call it DI, will be processed. And then thirdly, we should have a way of converting the digital back to what? Digital back to what? To analog. Because the real world in which we live is what? Is analog in nature. So here we call the device that can do that ADC, that is analog to digital converter. And then we have the digital system. This is where the digital system is. Processes it in strings of zeros and ones, that is in bits or bytes or in nimbles, which we are going to be seeing in our next class. And then an ability to do what? To convert it back to analog. So we have another device, digital to analog converter. So these 3 things must be in place for the system to be complete. Because the real world is in analog. And then our computers don't understand what we say. So there must be a way of doing that. For example, you type your name, A, B, C, D, E, F. The computer doesn't know what's A, B, C, D. But according to the ASCII code, which is a strings of ones and zeros, the computer can ascribe those strings to represent A or B or C as the case may be. In your text, you will see an example that is given to further illustrate the temperature control system that requires analog to digital conversion in order to allow the use of digital processing techniques. There you have a measuring device like a temperature device. This temperature is a measuring device, okay? And the real world which we live, like I said, is analog in nature because temperatures vary with time. So you have temperatures, maybe now you could measure, you have 36.5, you could have 36.9 the next minutes or seconds. So temperature is not constant. So these are examples of what analog signals. Other examples can be flow, can be pressure, could even be humidity, among other things. Now, when we have a measuring device such as temperature, the signal out of the temperature device is analog. Okay? And then it has to go through a process of converting analog signal to digital. And I told you it's an ADC. So you have ADC. So the analog digital converter will convert these analog signals to digital. Okay, so the output here will be what? Digital. Then the next stage is to process this signal. Okay, so we now process, we call this digital process. So it is processed. And then the next thing will be what? To convert it back to analog. So the next thing is what? Conversion with the DAC. So digital to analog. And then we have an output. Analog now goes to the what? To a controller. Goes to the controller. And then the temperature is adjusted. Adjust temperature. So what we mean here is that probably we want a temperature when it gets to a particular centigrade or Fahrenheit, depending on what you are using, that you want this controller to adjust the temperature, probably in a room. So this is made possible through to go through this process. So let's say the temperature here is 36.5, and then the maximum allowed temperature in the controller would be 35 degrees Celsius. Okay? So once it goes beyond that, the digital process, because this is, you can see it is analog, goes here, this is processed, converts back to analog, the controller sees it, it is above what is imputed in the controller. So the output will now be to adjust the temperature so as to get back what is required. So this is leveraging on the digital techniques by using ADC converters and DAC converters to adjust the temperature. There are many examples which you can find in the real world, like I was telling you about the computer, where you type your ABCD and then the computer processes it in digital form and then outputs it to you on the screen. But what has gone through is an analog to digital conversion through the process, digital processing, and then it comes to you back as an analog signal. In the digital world, there are a lot of number-based systems that are used, ranging from decimal to binary to octal and to hexadecimal. But the most familiar to us is the decimal system. We'll talk more about that in the next class, which is on number-based system. Until we see them, do have a nice